Good evening. We'll just wait a little bit longer to let a few more people get logged on. We were a little bit quick off the mark last time. Numbers are building steadily. We have about 30 to 40 people logged on at the moment. I think we're expecting somewhere around 79. So we'll just give it another 30 seconds or so if you're okay with that. So please just be patient for a little while. Thank you. We're up to 50 or so now, which is quite good. Maybe another 10 or 15 seconds and then we'll get started. Okay, I think we'll make a start. We've got about 53 people online and logged in, so that's quite good. Right. Okay. Good evening and welcome to the second in our series of webinars. I'm William Stockdale, Chair of Thornton-Le-Street History Group. We're delighted to welcome tonight's speaker, Alistair Oswald from the University of York. Al will be talking about Lidar-based landscape research, a road to the future. Al was heavily involved in our Roads to the Past project. His input was greatly appreciated and gave us a much better understanding of our landscape. There will be an opportunity to ask questions. Please just type them into the Q&A box. I'll now hand over to Al. Thank you.
Thank you very much, William. Good evening, everyone. And indeed, thank you to the group as a whole for inviting me back. There we are, right. And really, it's another symptom of the strangeness of these times that we're living through that I'm doing this talk at all. Whenever I've recorded a talk previously, it's because a large proportion of the undergraduates who should be in the lecture theatre are still in bed. But here I am, if not in my bed, just next to it, and I hope you're all wide awake. Now, as Bill said, I was involved in the Roads to the Past project, and Lidar was involved in the Roads to the Past project. And so I thought this might be an apt moment as you come to the end of the Roads to the Past project to look to the future, but also to review how we've got to the point we're at with Lidar. It's become commonly used in many archaeological projects these days, but I think the process by which we got to this point isn't always well understood. And in my former role as an English heritage researcher, I was in charge of the landscape investigation team for the north of England, based in York. And I was involved in a sequence of projects which really established Lidar as a way forward. So I thought we'd look at those before looking to the future. So, oh, what's happened there? Sorry, we're having technical difficulties. The screen has gone blank. There we are, good. Thank goodness for that. So the sites and landscapes I'll be dealing with this evening, they represent a chronological sequence, starting with Scordale, which is the black square on the right-hand maplet there. And then we'll be moving south from there to Grassington, and then back north to look at the Minor Farmer Landscapes project, which was carried out by English Heritage, and then to a number of other surveys in the North Pennines area of outstanding natural beauty. I want to look as well at the rationales behind our choice of LiDAR and the methodologies we adopted, so that you have a better understanding of why we were experimenting with LiDAR in the way we were. This is going back 15 years or so now. The most important stimuli for our new methodologies were a couple of pieces of European legislation. The first of these was the Water Framework Directive, which the UK became a signatory to in the year 2000. And this was a piece of legislation that required European member states to work towards a sort of set of minimum standards for their freshwater, both lakes and rivers, in terms of not just water quality, but their ecology, amenity value, and so on. To really the whole sort of gamut of things that water is used for. A second piece of European legislation was the European Landscape Convention, which we signed up to in the same year. And that required European member states to consider landscape in its broadest sense, that is both physical and cultural, in designing and implementing any major infrastructural project. English Heritage commissioned Oxford Archaeology North to carry out a trial survey of the Ribble catchment. And this fed into the River Basin Management Plan. So a River Basin Management Plan was required for every separate river basin in the UK and indeed the rest of Europe. Oxford Archaeology North's work produced this popular booklet and a very workmanlike overview of the historic environment within the Ribble Valley. But we felt there was something slightly missing from it. We felt that more could be done to develop narratives of landscape that integrated the sort of the natural environment, the river, and the human landscape, the historic environment, to make clear that the things that people did in that landscape were in part a consequence of the presence of the river, and that the way the river itself behaved was equally a consequence of how people behaved around it. So very much a sort of an interwoven history of the watercourse and its landscape, rather than separating out the historic environment from everything else. Around this time, there are another series of key issues for government agencies. From the point of view of English Heritage at that time, now Historic England, the key issue really was the terrible damage being inflicted on scheduled sites and landscapes, particularly industrial sites and landscapes, by erosion. And this was widely agreed to be a consequence of climate change and the increased frequency and severity of flash floods and so on. This is one example in Scordale, which we'll be looking at it in more detail in a minute. So that was Historic England's, English Heritage's concern. But from the point of view of the Environment Agency, looking at it from the other end of the telescope, if you like, the problem was very much about the damage from industrial sites. Places like these lead mines in Scordale, releasing vast quantities of toxins into the watercourse. The plume of toxicity going out into the North Sea stretches out for almost 30 miles into the North Sea. So not only the watercourse itself, but also the saltwater bodies into which these rivers flow. And both organisations felt that it was time to develop and disseminate new methodologies for understanding how these landscapes had developed through time, with a view to underpinning new ways of managing those landscapes in the future, Europe-wide. From the point of view of natural England, it was a different issue again. Those of you who've had any dealings with the historic environment and the natural environment, you'll know very well that the natural environment has a great deal more clout in government circles and a great deal more money as a result. And natural England's interest really was in the very rare plant communities in particular, which thrive on these metal-rich environments. Another issue was that everybody recognised that while national parks were relatively well resourced and researched, areas of outstanding natural beauty were very much the poor cousins. And it was agreed by everyone that supporting areas of outstanding natural beauty was a very important priority. This is what Scordale looks like. The area on the left-hand maplet that you can see, which is outlined in red, the larger of the two areas there, is the extent of a scheduled ancient monument, which comprises mining remains going from the medieval period right through to the early 20th century. And Scordale is within the Warcop Army Training Area. It's owned by the MOD. And the MOD were scratching their heads really as to how to deal with the terrible erosion that is taking place in this valley, which is impacting not just on the mines and not just on the water quality, but actually on infrastructure downstream. So we have roads and bridges being washed away as this erosion worsens. And with this being the MOD's problem, they were concerned to do something about it, not just for themselves, but for the river basin as a whole. Scordale, as you can see from this image, is a valley that has been utterly transformed by mining over several centuries. This is what that same view used to look like in the early 20th century. You can see that all those structures have gone now. Many preceding structures have also disappeared, and all that we're really left with is the archaeological deposits on and just below the surface. And the MOD, as a first step in the solution, were advised and prepared to fund an aerial survey. They collected very high resolution aerial imagery, and this was then used as the basis for mapping the archaeological remains, the visible archaeological remains, to national mapping program standards. So the National Mapping Program, for those of you who haven't heard of it, is a program that's been going on for many years, using aerial photographs and, to a lesser extent, historic maps to map all visible remains on those photographs throughout the country. So that this happens in sort of blocks, county by county sometimes, or sometimes by national park or area of outstanding natural beauty, or in this case, it was just the Warcop Army Training Area, which was mapped. And it was felt by myself and other people within English Heritage that actually, given that there were relatively few non-firing days on the Warcop estate, that the best use of our time was to get the aerial mapping done first, and then to take those maps out into the field and ground truth them. I find that expression ground truthing rather odious, actually. You're never really finding the truth anyway, but there we are. That's the accepted expression. In other words, to take the plots that were derived from the aerial imagery and go and double check them on the ground. This, by the way, the image that it's on screen now is obviously not the vertical aerial photography. We were able to drape the vertical imagery over ground models of the valley so that what you get is this sort of pseudo 3D imagery. It didn't quite work out as we were anticipating. When we took the aerial transcriptions out into the field to double check and just as we thought, as we were anticipating, just sort of tickle them up slightly, we found that actually there were a great deal of features which hadn't been recognized through the desk-based transcription of the aerial imagery. Things, for example, like rubble structures that were built within larger rubble spreads. Things like this line of rushes in the photograph, which is actually the course of a leat, which hadn't been, a water channel in other words, which hadn't been picked up from the air. There were individual boundary stones and so on. So all sorts of things that weren't visible from the air. And in particular, we found that the aerial transcription had not succeeded always in identifying stratigraphic relationships, in other words, temporal relationships, chronological relationships between different features. And really those stratigraphic relationships are absolutely critical to understanding how a landscape develops. Unless you understand what comes first and what comes next, you can't build up that sort of narrative of how a landscape has developed through time. So far from just doing a sort of minor tarting up exercise, we found that we were, in many cases, almost starting from scratch, but not quite, because we had the benefit of the aerial imagery, and we found that a lot of the things that we were encountering in the field that hadn't been spotted during the desk-based transcription were actually visible on the aerial photograph, but only once you knew they were there. In other words, you took the aerial photograph with you and you had an accurate survey available to you, but you only found the interesting things by looking on the ground itself. You could then mark them up pretty accurately on the aerial imagery. So what the MOD ended up with is what's called a GIS, a Geographical Information System. In other words, a sort of dynamic map which shows all the different features in the valley. We mapped about a sort of 4-kilometer length of the valley and picked up hundreds and hundreds of features dating right through from the Bronze Age right through to the modern era. And we picked up a good deal of modern ordnance well, not literally picked it up, but we identified a good deal of modern ordnance in the first place, in the process, which the MOD were very glad about too. But this dynamic map theoretically allows the MOD to manage, to know where things are, so that the squaddies who are on manoeuvres there don't do any damage to archaeological features unwittingly. In terms of managing the erosion problems, well, that was a rather different issue. Our conclusion was rather different from what had become the accepted story. The accepted story was that this was all down to climate change, basically. A report was commissioned by Durham University into the fluvial dynamics, and that said, well, it's largely down to climate change, and there's very little that can be done about that. But very presciently, that report also pointed out that the long history of earlier land use would have had an impact too. And that's very much what our conclusion was, that actually really it was the cessation of the management of the lead works in the early 20th century, which led to the demise of the highly regulated water system and its attempt to return to a sort of pseudo-natural water pattern, which was causing the erosion. With this observation in mind, we were asked to, again by colleagues in English Heritage, now Historic England, to carry out some survey work at Grussington on the lead mines there. And this was a piece of casework which had arisen because the estate, which owns the land, had been carrying out works of various sorts, including putting in these little gutters and digging drains and so on, and patching the road surface to allow it to be used for grouse shooting and so on. But this was doing damage to the Scheduled Ancient Monument. And we were asked to go and really record the damage and see if we could come up with some reasonable solution that would allow everyone to use this landscape more amicably. And our conclusion was rather similar, that it all had to do with the dynamics of water flowing around the landscape. My friend and former colleague Stuart Ainsworth, who I expect will be very familiar to many of you from his routine appearances on Time Team, wrote the report on this. And there's a quote from that report which I'd like to share with you because it always makes me laugh. He said, "Fortunately, the 5 days of fieldwork coincide with a period of heavy, continuous rain, which allowed us to observe and record the fluvial dynamics in detail." I thought that was a classic example of seeing the silver lining to a cloud, quite literally. And as you can see from this photograph, it might look hazy and fuzzy. That's because there was so much, it was raining so hard and there was so much water on the lens of the camera that Stuart was unable to take a clear photo. But I think you can see from these images how water management is absolutely crucial if you're going to prevent erosion occurring on these lead works, and thus reduce or manage the amount of pollution creeping into the watercourses. Our realization was that because a lot of the most fine and toxic deposits, the really sort of the silty deposits, which were the sort of end products of the sequence of lead ore processing, they were located very close to watercourses originally in order to both harness the power through water wheels and for washing and so on, cleaning the ore. And of course that meant that as the watercourses gradually returned to their natural trends, their natural courses, they were starting to erode into these highly toxic deposits. So again, our conclusion was that in order to address the problem of toxicity in the watercourses and damage to the site, what you had to do was recommence managing the water supply rather in the way that it had been during the lifetime, the active use of these mining landscapes. And again, this time, rather than commissioning specialist photography, we had very detailed aerial photography available to us. It's not quite Google Earth imagery. It's more, it's higher resolution than that. But we had this available to us through a pan-governmental agreement. And so we were able to produce a dynamic map again, a GIS, showing where all the features of interest were, and also mapping the watercourses and both artificial and natural, which were contributing to the problems there. With a new methodology and a new set of theories about lead mining landscapes in mind, we wanted to try this out on a larger scale. So we moved back to the North Pennines area of outstanding natural beauty. And this was an area, an AONB, which has its own set of issues, of problems. The first is that it has by far the UK's worst river pollution. It will never reach the standards required by the European legislation, but the Environment Agency can't account for about 80% of the pollution. They can't source 80% of the pollution. Some of it is because it's just naturally in the water. Others, they can't pinpoint where the lead toxins are actually coming from. We felt there was a role for archaeology in helping them to pinpoint those sources. Oh, it's died again. No, there we are. Slow, sorry. We'll go back one. So from the point of view of getting our message across, it's the largest AONB in England, and it covers multiple government regions and 3 different counties, in fact. So we were talking to a fairly broad spectrum of players. In terms of its historic environment, it is seriously under-researched as well. It only had 2 prehistoric monuments had been identified within the whole of the area we were looking at, and almost everything that had been identified was post-medieval industrial activity. So there were many other industries going on apart from lead mining, but these didn't really feature in the record at all. So we wanted to investigate the interplay between these different industries. And there were only 3 scheduled ancient monuments which were not industrial in character. There were a tiny number of listed buildings. Sorry, I'm having to wait for this. And from the point of view of development control, the issue being experienced in the ONB and elsewhere, I know, is that so-called 4-wheel drive weekenders were turning up and redeveloping remote farmsteads which had previously been inaccessible and ripping out important features. In many cases, they were perfectly well intentioned. They thought they were doing the right thing, but they were actually really destroying important historic features simply because there was no real understanding of what the important features were. And there was very little heritage tourism in the AONB, apart from Nenthead and Killop mines. And those of you who've been there will know that Nenthead has since been shut down anyway. So we came up with the Minor Farmer Landscapes project, and it was conceived as a series of modules, each effectively freestanding. And the reason I mention this is if you're planning a large community project, I think it's a fairly good model to think of things in terms of discrete, self-contained modules which don't impact on each other if they can't be delivered. Basically, the first few modules are the ones that we're going to be dealing with today. So we started by carrying out a conventional national mapping program exercise, looking at all the existing aerial photographs taken by the RAF and the Ordnance Survey and so on, and seeing how many new archaeological sites and landscapes and features could be detected as a desk-based exercise. But we then commissioned a suite of new aerial imagery and then measured how much more could be detected, again as a desk-based exercise, by using this new imagery. And one of those data sets was Lidar. The first time really that it had been tested as quite deliberately and purposefully in this way. And we then also carried out a field survey, going out into the field and looking at the humps and bumps on the ground with and without the Lidar in hand to see how much more, if anything, we could detect on the ground than was detectable either through the conventional aerial photographs, the newly commissioned aerial imagery, and the Lidar. And so this was a sort of exhaustive testing of the benefits of these different data sets, all of which have now become quite commonly available. But at the time, this was really cutting edge stuff. So this was the first set of aerial imagery we commissioned. It was just conventional high resolution vertical color aerial photography, and it was flown in the spring because we discovered that many of the metallophytic species have white flowers, which if you screen the images, you can detect the extent of these plant communities. You can filter that out and pinpoint them on the ground just through using the photography remotely. We also commissioned infrared imagery, and as you can see, this shows up a lot of the same stuff, but also some things in different ways that make it easier to understand sometimes. We commissioned, as I said, Lidar. So this is not an image, it's not a photograph, this is pure data that you're looking at here. And this is, as if to prove the point, this was actually flown at night. It has to be flown on a very still night, and the surface of the ground is scanned in great detail. What we're looking at here is a digital surface model, a DSM, which captures the whole surface, including things like dry stone walls, and you can see coniferous plantations there. But the groundbreaking thing about Lidar is that you can use various algorithms to strip off those surface features and effectively see beneath the trees and beneath dry stone walls and so on, and buildings. And that imagery is called a digital terrain model. And we flew, or the quality of the data we asked for was at 25 centimeters. That means there's one data point in every 25 square centimeters. But we then degraded it so that we could see what was the best resolution for carrying out archaeological and indeed other forms of environmental survey, landscape survey. And we found that 25 centimeter resolution, the original resolution we'd commissioned, was actually too good in some ways. The half-meter resolution was perfectly adequate. And indeed, even the 1 meter resolution, when it was degraded that far, was usable too. Now that's very good news, because 1 meter resolution LiDAR has now been made available for free by the Environment Agency for a great deal of the UK, and the Environment Agency has committed itself to making available imagery at that standard or better for the whole country. So that means that we will have, as a country, a tremendous resource for both for archaeological research and indeed for lots of other projects. We got an early success with this area of the forestry plantation here, where the AONB asked us if there was anything we could contribute, and I think they had fairly low expectations. This area was going to be clear felled, and they asked us if there was anything they should know about it before they started. And we were able to point out that within that area were 2 lengths of tramway were detectable, and immediately above them there were workings hidden in the plantation. Lead workings, obviously. Therefore, had this clear felling been done without great sensitivity, all the lead toxins in the ground would have been released immediately back into the watercourses and presumably caused the death of lots of trout way downstream and indeed out into the North Sea. So the field methodology we developed was ultimately, this is Stuart Ainsworth, by the way, in case you haven't recognised him. The field methodology was to take printed sheets of LiDAR, printed onto waterproof permatrace, out into the field, along with a sort of package of different aerial imagery, historic maps and so on, and just to sort of use coloured pens to annotate the LiDAR image with different features and how they related to each other. And these are excerpts of one of Stuart's field notebooks, and you can see how he's used them to clarify the chronological relationships between different features and made quite detailed notes on them as he's been going along. And the outcome of all this was really designed to be better management of the landscape by the Environment Agency. So, for example, we were able to show them that one particular watercourse did this, and that it went through not one mine, not two mines, not even three mines, but there were also other historic features involved in that water trajectory. There was a Bronze Age head dike, a 20th century drain, a medieval or earlier holloway. I suspect it's actually a good deal earlier than the medieval period. It went past a late 18th century house and actually supplied the water to it. Flowed down a Roman hush, in other words, one of these means of extracting lead by releasing a deluge of water down a valley. And then eventually, having flowed through yet another mine, delivered that water out into the River South Tyne. So we hoped that understanding the fluvial pathways was going to allow the Environment Agency to understand how toxins were reaching the major rivers, and also, in a sense, give some impetus to the management and protection of the archaeological features involved along the way. I'm just briefly going to mention the Roman fort at Witley Castle, probably known in the Roman period as Epiarchum. This is very much the jewel in the crown of the North Pennines AONB, but a site barely visited by anyone until we began our research there, and that research led to the founding of a trust to look after it. And you would think that within that, a monument of that importance would have been looked at exhaustively, but no. Within literally spitting distance, you can just see the defences of the fort at the top of this LiDAR image. Literally within a stone's throw of the corner of the fort, there is a native settlement, presumably broadly contemporary or slightly earlier than the Roman fort, and a second one not very far away, spanning a dry stone wall. You're looking in that photograph at the bit of it that isn't very well preserved, that's been ploughed over to the northeast of the dry stone wall. But we mapped it on the ground, and that's what it looks like. That's the humps and bumps. You can see the marks of roundhouses and little yards and pens, and a sort of an encircling bank protecting the whole thing, presumably with a hedge or a fence running along the top of it. Very slow slide transitions. Sorry if you're getting the same thing. Fading in very slowly. There we are. And we, as at Thornton-Le-Street, there was a community excavation took place, and that was very helpful in dating these settlements. There were also unexpected dividends. The excavations led people to turn up with things they had in their back garden, like this sculpture, which is probably well, it's Celtic in form, but probably produced by a Roman auxiliary unit based on its style. There were a lot of other sites we picked up on the LiDAR as well. This one in particular was interesting because of its outer corral. We'd seen corrals like this working in Northumberland Cheviots. So you have the settlement at the centre surrounded by a corral, often with a sort of droveway leading out through arable fields round about. And there were other settlements associated with early arable cultivation as well. What you can see, the stripes on this are medieval ploughing over the top. Most complicated of all, perhaps, was this one at Gossip Gate. We mapped that on the ground as well. And again, you can see that this is extraordinary. It's a series of little compounds, each with several roundhouses in it. But in this case, flanking what can only be described as a high street. This is a Roman come native village laid out very much like a medieval village. And we came in total across about 23 late prehistoric settlements which hadn't been recognised before, as well as many, many other sites, of course. One of our suspicions is that Alston, whose earliest recorded name is Old Toonby, which means Old Town Farm in Norse, might be the site of another of these settlements. The churchyard there is suspiciously circular and built of very large, uncharacteristically large stones. Just mention another site, Battle Green, just to show you what you can do with LiDAR. This is what it looks like on the initial LiDAR imagery we commissioned. And we're going to be looking at that area in particular. You can use that data, you can turn it, twist it, and light it in different ways. You can highlight the different heights in different ways and produce all sorts of imagery. Some of these things that look particularly impressive actually are just natural features. They're just natural sinkholes. But this thing here may have started life as a natural sinkhole, but in its eventual form, it was a colossal crater created by a sequence of different mining activities, from open cast to digging shafts. And the area downslope, or down the valley from that, was particularly interesting. So this is the kind of information you can't get by looking at LiDAR. You'll notice how the mosses are this virulent green. That's because of the toxicity of the soil underneath. It's very lead rich, very fine lead deposits coming up in the rabbit burrows there. And this seems to be the area where they were processing what came out of that enormous pit, and possibly some of the other sinkholes as well. And just to show you how, after a considerable length of time, even now the lead toxicity is enough to kill the grass on the surface. And it's possible that this mining is medieval, but our suspicion is that it might even be Roman, which is the first time that sort of date of mining has been identified in the North Pennines. And again, we produced a conventional survey. It's debatable whether that was any more use than the LiDAR. Based on this model, the area of outstanding natural beauty produced another Heritage Lottery funded project. They looked at the Allen Valleys and Hexhamshire. And this was the availability of LiDAR within that area already. So LiDAR flown by the Environment Agency, freely available. So a great deal of this block of land was already, the LiDAR was there. It was at 1 meter resolution and it was usable for survey. But in this case, rather than English Heritage professionals doing it, the work was done by volunteers living in many cases in the local community, in the local area. And they produced things like this. They just marked up maps. Either this one was done digitally, some of them were done literally using pens and paper, as we had done during the Minor Farmer project. And they pinpointed a very large numbers of sites. as you can see from this. The bulk of them are post-medieval, but there is a very large number still of prehistoric and Roman sites and medieval sites, all of which were entirely new to the record. And since then, a whole series of other projects have been carried out using LiDAR and using volunteers to plot whatever they can see on individual LiDAR kilometre squares. It's proved a very effective means of survey. So turning to Thornton-Le-Street, well, you already had LiDAR and were making use of it. But I would suggest that there's a great deal more use to be made of it. Every time some of you may know, I've done recently a series of guided tours around the village, and as we've handed out copies of the LiDAR imagery to people to look at, and for me to point out things on it as we're going around. On every occasion, someone has said, well, what's this in this field up here? Or what's this thing over here? And this is a largely arable landscape, unlike the North Pennines, of course, which is largely pastoral. And yet, even within this largely arable landscape, there are things, perhaps things you can recognize on this image in front of you, which are still there as low earthworks, or in some cases quite prominent earthworks. And people would say, well, what is this? And my response to that is, I don't know. It's really up to you to go and have a look at it. Without going and having a look, there's no way of knowing. You can certainly see that there's something there on the LiDAR. The question is, what is it? And that really, you're only going to start to be able to resolve that by looking at it on the ground, by looking at changes in vegetation, by looking at potentially finds on the surface, by looking at the context of that earthwork and its relationship to other earthworks round about. So I suppose in terms of roads to the future, my advice to you as a group, and those of you who aren't part of this group may want to do something similar in your own areas of interest, is to just study the LiDAR, become curious about it, and go out and investigate whatever puzzles you. Ironically, these days, the availability of LiDAR and all the other data sets we have available to us, like Google Earth and so on, we have this tremendous range of remotely sensed data sets which are now freely available throughout the country. And we have an embarrassment of riches in that sense. The problem is that actually, in terms of going out and making sense of what you can see on the LiDAR on the ground, the traditional skills of field survey, going out and looking at things carefully and trying to make sense of what you see with the naked eye, those are the skills that are in very short supply nationally now. So for the past few years, Stuart and I have been running a landscape archaeology masterclass, or sometimes two every year, at Epiarchum, the Roman fort. And if anyone's interested in taking this further, I would very much encourage you to go to the Epiarchum website, and you'll be able to find out what's happening in the months beyond COVID, all being well. We actually have a backlog of people we were hoping to deal with this summer who will be trained next year, all being well, touch wood. So you might be signing up for a course in 2022, goodness me, but I would very much encourage you to come along. We cover a very diverse range of landscape investigation skills in the course of a long weekend, and what better place to do it really than this extraordinary archaeological landscape, which is Epiarchum, the Roman fort at Whitley Castle. So I'm going to leave my talk there, and if there are any questions you want to put to me, then I hope you've used the question and answer box as Bill advised at the start. And thank you all very much for listening.
Right, we have a question about Lidar.
Mm-hmm.
What is the best way of processing the Lidar, do you think?
Now that varies very much from depending on the landscape from site to site. Processing that works very well on one particular site may not work brilliantly on another. So there are all sorts of different options, and it's worth just playing around and seeing what works in that particular environment. The very popular methods of processing these images, and I think actually if you were to think about that image of Thornton-Le-Street again, I think it was used on that. There's a technique called principal components analysis, which can be done from a number of different directions. So you can take the, if it is what it sounds like really, it takes the principal components of a particular piece of ground and highlights them. There is hill shading. Hill shading from particular angles will show up different things. So changing the angle of the lighting and the direction of the lighting will show up different things. You can do it from 8 different directions simultaneously, even more than that if you want to, but 8 is a reasonable way of doing it. So that will effectively, it's like having 8 spotlights shining across the topography at very low level, and that will reveal features regardless of what direction they're best lit from, in a way. Sunburst is another favorite of mine. That highlights things very effectively. But really my advice is just to experiment and see what works, because no single process works for every site.
Right, there are lots of questions about Lidar. Somebody's asking, where can you find the Lidar data produced by the Environment Agency? Is there a URL?
There is. If you Google Environment Agency Lidar, you will get straight there, I think.
Another question, how is Lidar collected? By plane or by drone?
Both is the answer. So originally, it was quite a large box, and it had to be fixed onto the underside of a light airplane. The conditions for flying are extremely important. It has to be very still, and that's why the flying in the North Pennines was done at night, because actually the wind drops slightly at night in the North Pennines. So flying after dark allowed the plane to fly in level, straight trajectories to collect the data. But as LiDAR has got more and more popular, the size of the equipment has come down and down. So it's now perfectly possible to mount LiDAR on a drone and send it up, and the resolution of the data you can get is now far, far higher than was accessible to us 10 years ago. That said, whether it actually adds anything is, I think, debatable. So the 1 meter LiDAR, which the Environment Agency make available, is captured by plane and sometimes by helicopter too. And that is a very useful resource indeed for archaeological survey.
There's a comment that the free RVT tool can be quite helpful.
Yes.
Relief visualization.
There are, yes, that's right. There are some very good online guides which are available now, actually. This talk is more or less runs in parallel to an article that was published by Stuart and myself and Dave Went in the annual conference proceedings produced by the Dales Archaeological Research Group. which was published a couple of months ago now. And that has, in that booklet, the article by us has a number of useful tools and references to publications that are available both as hard copy and online, which give you really good and straightforward ways of processing LiDAR in the comfort of your own home.
And then Historic England produced, or English Heritage produced, a book on LiDAR, didn't they?
They did, yeah. It's called The Light Fantastic. And it's it has been reprinted. It's available online if you want to Google The Light Fantastic. I would say that is slightly outdated now, actually, and there are more user-friendly sort of guides to how to actually go about the mechanics of doing processing available online. So some really good toolkits and some really good written guidance as well available now.
There's a comment by people who were involved in some LiDAR landscapes projects, and their main point is, how does a community group make their project manageable so they don't get overwhelmed by data?
Yeah, I think that is a danger. I think the way it was tackled in the projects I was just talking about were on a kilometre square by kilometre square basis, so that everyone had, you know, a bite-sized chunk to deal with, and gradually that mounted up. But yes, there is a real danger, I think, in trying to do too much and coming up with an all singing and all dancing project, which involves maybe excavation and field walking and geophysics and so on. You end up with a blunderbuss rather than a rifle. But I would say, actually, you know, targeting a relatively small area, perhaps, doing it kilometre by kilometre, and the step that hasn't been taken by some of those projects is actually going out into the field and looking at what's been found at people's desks on the ground. So that's another step for people to take.
That's great. Thank you very much, Al. There are lots more questions, but I'll just hand over to Bill now.
I'm sorry we can't answer them all.
Okay, well, thank you, Al. I mean, tonight's webinar was very, very thought-provoking. So we really are looking forward to working with you again in the near future. We do hope that everybody's enjoyed the presentation, but we would welcome your feedback. It is quite important. It helps us focus what we're likely to be trying to do next. Okay, I've got to thank the Lottery Heritage Fund, without whose support this webinar would not have gone on. And I'm also going to use the opportunity to plug our book again. It's still available. It's a lovely book. There's a LiDAR image in it somewhere as well, and Al has had a significant input. So please, if you're interested in it, have a look on our website, or you could call me on 01845 527 717, and we'll gladly sell you one of the books. Our next webinar is on Thursday, the 14th of January, when we have Dr. John Kenny, and he's going to talk to us about the historic landscape of a medieval moated manor site in the Vale of York. So that sounds really good, really exciting. Until then, please do keep safe and well, and best wishes to you all for Christmas and the New Year. Good night.